Hi, I'm Saket Bansal, and in this video, I'm sharing you how you can improve your Retrieval Augmented Generation RAG system using VectorDB. The idea of RAG is it can provide you a better grounded answers. So initially, I will show you quickly 3 slides so that the concept is clear among ourselves, and then we explore some tools which can help us in creating that particular Retrieval Augmented Generation as a working model. So I share my experiment also once we are done with the concepts. So here, the idea of retrieval augmented generation is that you have a knowledge base. So say I have information about various project management concepts. Someone is asking, what is risk management? Yeah. So I need to find out what are the appropriate sources where I have discussed risk management. And along with those sources, I give a query to a large language model and say, okay, give me an answer to this particular client about what is risk management. Yeah. So the answer is augmented by my content. Rather than just I'm relying on a model, LLM model, to answer it, I'm also providing grounding. I'm also providing something which should be considered. So it becomes more like my answer rather than just a pure LLM answer. So that's the goal. And that's the overall purpose we are exploring. Now we are exploring with the vector DB, how we can probably make it happen. So at a super high level, we can say this is like a high level architecture. So we have a question coming in. Yeah. I need to convert that question into vector format. Yeah. So 1-0 format rather than a text format. And I have already prepared a knowledge base of my content inside another database where it is stored in the vector format, 1-0 format, not in a text format. So when the question is coming, I pick up the question, convert that question into 1-0 language, vector language, and then I query the vector database where my knowledge base is also stored in a 1-0 language. And then using the proximity of those words and the documents which are there, in a way, the vectors which are there, the vector DB shows me some of the possible places which can used for answering this query. Yeah, the query is happening in the 1-0 mode. And once the result comes from the vector DB, I get the result, and the result get converted into the text, the same the file which we shared there. So it picks up those appropriate files using that the vector query and a proximity, and then the large language model gets that selected text which is coming from my database and the user question and some instruction how should the LLM behave, and it generates the answer. That's it. Yeah, that's the high level architecture. I understand it might be confusing, so let's explore in a one by one. So we need to first ingest the data and then we need to serve the query. Yeah, so I need to create a vector storage which is containing all my ideas into a searchable, manageable chunks. And then when the query is coming, I need to make sure I'm picking the data from this particular source. Yeah, so that's the overall vector DB based RAG. Now, so ingestion process is like I pick up the information, I clean them, I slice them, and I create appropriate structure of it. Then I use APIs, Gemini API, to convert that text into the vector format. And then I store that into a vector database, yeah, with the metadata. And so this is like I prepare. And then I have a serving, which is whenever the query is coming, I find the similarity search by querying this vector DB, and it gives me some fetch documents and the information about it. I submit that information to the LLM, and LLM generates the answer. Yeah. I know it might be looking confusing. Let's see how do we do it. Yeah, with the help of an example. So right now I created using the make.com. Yeah, again, it helps me to connect various APIs calls and other stuff. So I use that. So let me show you my working model for this particular use case. So first thing is I created an account on pinecone.io. Yeah. So what it is, it's a vector DB. I could use Supabase and other vector DBs also, but I just, for an example, I created a account. It's a free account which I created. Now, once I want to store my information, I can I want to insert here. Yeah, so it's a special format thing. And once I insert these things, it will look like something like this. Yeah, so this is like records got created in this particular Pinecone. So I have a database which is a Pinecone, which is a vector DB. Now you may use other vector DB database also, which is supporting this type of storage. So I need to populate it. So first problem is, what should I put? So some of you who work with us for preparing for PMP and all, you may know that we have a PMP short videos. It's like around 300 plus videos, which covers the idea of the whole PMP certification, concepts related to project management in a short format. So when I was thinking about this use case, I picked up 19 short videos from risk management topic. So I said, okay, these are the 19 risk management topics. And then I created the Google Drive of it. So say, okay, this all will go into a Google Drive. And there I said, okay, now I can connect that Google Drive. Let me show you my Google Drive as well. So that's a raw data preparation. It is like no system is needed. You need to have knowledge before your AI can pull that knowledge. Yeah. So that's I think in a real projects, when you do things, that's going to be the maximum time consuming activity you will do. So I created this risk AI as a folder. Let me show you here. Yeah. And in this particular folder, I added all my videos transcripts, yeah, text files. So there were 19. So I like a decision tree, expected monetary value. So I just open, you can also do it. They are openly, publicly available. So I opened each and every video, copied their transcript, yeah, here. So that's something I did. Yeah, each transcript is a 2 KB, maximum 4 KB, because later on YouTube allowed me to make up to 3 minutes short videos. So it was like that. So I created this TB. Now I need to put this information from my Google Drive to Pinecone. Yeah, so that's my Pinecone database. Yeah, that's my ingestion process. And once it is there, then whenever the query will come, I can query and provide the information there. So in order to make that happen, I created a workflow in my make so that this whole process can go to Vector DB. So here I had a Google Drive. Then I download Google Drive one by one. Yeah, Google Drive directory. So I connected the Google Drive directory. I downloaded each and every file one by one. Then there is a tool to clean up the data because a lot of information comes along with the Google Drive files. Yeah, so that's the usual thing you do in a make, like cleaning of your code. And then I need to call Gemini, Gemini specific API, so that it can convert this into the vector format. And then I call the Pinecone API to save this into vector format. That's it. Yeah, so this is the process. Now I can show you a little bit how it works. So here you can say that the operation happened and it found the content of the Google Drive. This is something you can little bit see as well. This is how the information about various file came. So it picked up the information in this particular mode, and it says, these are the possible bundles. Yeah, so it's like 19 files, as you know. So a particular step one where we picked up the Google Drive, it pulled the information of these 19 files. Yeah, so that was the case. Then when I have to download the file, this is all is your make.com. Yeah, so you can see each operation results it into picking up the file, and then it could produce the output somewhere here, and you have informations, and finally it talks about file name and other, and then you have a data which is also coming. Now that's a little tricky thing. When you read the file in Google Drive, it comes in a ASCII format, so it just gives you some numbers. Yeah, so it is not a text. Yeah, that's a little way. And then I have to convert that into text. So I create a small tool here where it just convert data into toString. Yeah, so when the toString is created, it becomes a clear text. Yeah, so that's a technical step because I can't read the text directly here. Yeah, in this particular setup, if I'm using some text reader or something, I could have done that as well. So now, as a result of step 3, I have that each and every file has a clear text, and this clear text is my transcript. You can see the line space and all, because when I copied the transcript from YouTube, it has a lot of new line character because small statements are made. So I let it like this only. It has all the inputs. Yeah, so all my files are finally available here in the text format. Yeah, so this is something you can see. All 19 files are available here. Yeah, so this is ingestion process we are exploring. Now I'm just preparing the right data. Then I pulled I need to call the Google. And the idea of Google, like we called for all 19 files, Google API was called. Now here you can see that each bundle, there is a input which is going as a text file, and the output is uh, this is your vector input. Yeah. So these are the numbers which are like a vector arrays, and they will get stored. Yeah, so we are just storing this. We are not storing the detail of our exact, like we can store the metadata, but the real search will happen around these numbers. Yeah, so this is something we are storing. We are ready to store. Yeah, so this is like we called the Gemini API, or anyone who can convert the text into a vector. We called it, and based on that, finally I put this information into the vector database. Yeah, so it is something going into calling my Pinecone URL, and then finally adding the data, and he's saying, okay, this is something one has been done. This was a header, and this is how you have added it. Yeah. So I run this process. I can make it automated run also. Whenever new file get added into the drive, this workflow can run. It could be a periodic workflow where we upload our information into the vector format to a Pinecone database. In this particular case, Pinecone database. Yeah. So this is an ingestion process. So now what we have is, after doing all this, we have these 19 records. Yeah, 19 records which are stored here. It has some metadata like document names and other things is also here. It is also having a text info. Yeah, so that metadata and easy to check things. My topic name is little weird up. Yeah, so I need to improve that. And I created a namespace. So again, without going much in detail, you understand this whole thing has been inserted now. Yeah, so this all is your information which you can see. You can fetch, you can see what is there, and it gives you all the information which is pulled in this particular space. And here you have a values. These are the values which we are interested in. These are the one which will really play a role in searching. So it's a long value in a numbers. Yeah. So this is done. Now, what do we do? This is a background work. Your data engineers and AI engineers will work and create this. After this, we need to focus on client side space. So I prepared a small demo using make again. So what I did now here, whenever you have a query, the query will go into, so I created two tools for this make AI agent. One is generate query and another is search Pinecone. So whenever I'm asking what is risk. Yeah, for example, in this particular case, I ask what is risk. So this particular tool will get used, generate query embed, and it produce it goes an input output as thing, and it produce this vector interpretation of what is risk. Yeah, so what is risk get converted into vector array. Yeah. Now this particular thing I will query to Pinecone. Yeah. So when I go again into Pinecone here, yeah. So this is a step one. Step one is that we are converting the information which we have into the question which we got into the vector format. Then I search. Yeah, I will search the Pinecone, and it goes like this, and then it has a lot of data, and then output comes. And output comes to me in a text format. Yeah. So the output which we are picking up from there. So this vector information is used for searching. The output is given into text because our LLM understand text. And now what all files? Now the output will be selecting the appropriate files. Yeah, so that's the key. Appropriate files will get selected. Now, how do you know? So you need to define ktop. That's another technical things, like if you have a more possibilities need to be selected, then you can keep your ktop number high. If you want to keep it less, you can have a less number. Yeah. So the overall idea is that if I can also show it here, that comes into a little more clear manner. So the query went what is risk into the vector format. The output is like this. Yeah. So you can see the output data, and it produces the matches. So it produces 5 matches because my k value is 5. Yeah. So I'm saying that you will get some numbers. Based on that, look into your database and search what possibly things works, and bring up 5 files which make sense. And then those 5 files information, we will send it to the next level LLM, which will create answer out of those 5 files. Yeah. So now what is risk? This particular Pinecone picked up first file is around the Risk fundamental, yeah, very logical. Risk fundamental is something takes care of it. Then it picked up the file from the another one, which is a risk residual risk. Somehow it picked up something called residual risk file. That was another file of mine. And then it also picked up a qualitative risk analysis. Yeah, that's something it picked up. Then again, as we are going down, the relevance is becoming less. Yeah. Then risk management plan it picked up, and then it also picked up the information coming from risk list. Yeah, so these are the 5 files it picked up. If I can say k value 3, then it will only pick up 3. If I can say k value 10, then it will pick up 10 relevant file. So the experimentation will increase. The AI may not be able to create more accurate answer because they are getting a lot of information. That was the problem we are trying to solve here, yeah, by giving relevant information. So the value is here, that how the creating everything in a vector format helps us in finding the relevant file or a content, and this content can be fed back to the agent. Yeah. So in this particular case, this agent is working like a orchestrating agent. So first calling the converting the query into the vector format, then searching the vector formatted data to find out what are the relevant text, and then we are submitting all the text and submitting back to the agent, and agent is preparing the final answer. Yeah, so this is how we can do it. Now here I have just a format. I have given an instruction what the agent has to do. I have told, generate query embed, search Pinecone context. I given the whole steps. I'm also telling, if you are unable to find, then tell me that you are not getting it from RAG. Yeah. So now in order to test it, we can just do a chat here. Yeah, the make allows you to do it. You can have some other input format also. So for example, I can ask what is decision tree? Yeah, so I asked this query. Now you see the execution happening. Then it generated the query embed. That's the first thing happened because we need to convert that what is risk into some vector list of things. And then agent is figuring out what should I do with it. So that's the agent time. And now hopefully agent will call the search Pinecone, and then the Pinecone should provide some relevant files, and then we should have an answer. Now it is searching Pinecone. Search in Pinecone is done. So Pinecone has already provided some file, and then I got a reply. Yeah. So agent was thinking, now I have given instruction. Whenever you are giving an update, you need to give a RAG status, used, retrieved PMP context or not used PMP context. So I gave that information. So then it is giving the answer and explanation and some other things as per my instruction. That all is simple because whatever I have told, it is giving those answers appropriately. Yeah. So this way, in this case also, we can see what all files probably became as an input candidate, like the output from Pinecone and input candidate for the RAG system. So again, 5 because my k value is 5. Yeah, that's something we can see here. So you can see results empty here. Yeah, here matches. Yeah, matches and this thing. So it picked up the data from decision tree, the first one, which is very relevant because you should be talking about decision tree. Then it picked up the next one is probably, I should be creating the metadata only. Expected monetary value, it picked up the information from there because expected monetary value usually works along with the decision tree. Then the third file, it picked up influence diagram. You know that whenever decision tree becomes complicated, we pick up influence diagram. So I spoke about that in the video. That's why it picked up the information from there. Then it picked up the information from qualitative risk assessment. We know that decision tree is one of the qualitative, quantitative risk assessment. So I think the next one should be quantitative also. Yeah, residual risk. Yeah, so it could have put down quantitative also, but not picked up. Maybe depending upon the content. So usually I can keep a k value to 3, so it can give less information and can create more accurate answer. If I want to have more variability, I can give a more k value. So what is the purpose? You can see how you can scale your answering process using the RAG concept of VectorDB. In 2026, the new way of improving RAG is also getting promoted, page index, so which can provide good answers without using VectorDB as well. In future, what we see is the hybrid approaches where you use some answers coming from VectorDB, some coming using the idea of page index. So your solutions get improved over a period of time. New concepts keeps coming. But this is something, one of the foundational thing as a project manager we can learn, and it can help us in understanding and as well as talking to our engineers. May not necessary that you end up creating the ingestion and the query or serving pipeline yourself. Maybe you want to do it, but may not necessarily you will do it in your day-to-day work. But you understand that there are concepts like this which can improve your RAG system.